Doppler effect, same thing. Similarly, in wave optics, we are going to cover the contents which might not be in your syllabus, as in your textbook. But since they are included in the JEE's syllabus, we are going to cover them. So what are the contents we have, all in all, general? So lots of different concepts we have, starting off with a basic concept about nature of light. Then what are wavefronts? What is Huygen's principle? Huygen ये इंसान का नाम है, by the way. It's not Eugene, it's not Huygen, it's Huygen or Huygen's principle. Laws of reflections using HP बोले तो हैरी पॉटर नहीं, Huygen's principle. Interference, double slit experiment, fringe width, coherent sources, lots and lots of different things. Moving on to the diffraction with the width of maxima and minima, and finally ending with the radio telescope. So these are all the contents we are going to cover in our chapter wave optics, a topic which we have in our hand, which is wave optics. So starting off with a very basic concept about nature of light. Now, when we consider a nature of light, yes, Neeraj, what is health percentage? Hey, HP health percentage नहीं होता, AD. It's Huygens principle. आगे तो वैसे HP तो बहुत कुछ होता है, Hewlett Packard भी होता है. Okay, हाँ. When we consider nature of light, okay, the first type of nature which we are going to consider, it's called as corpuscular nature of light. Okay, now what do you mean by corpuscular nature of light? The very first thing, or the very first understanding of this was given by a scientist named René Descartes. Okay, he gave this particular concept about, he was actually a mathematician and a physicist, a French mathematician. He considered the shadows which are formed, the images which are formed by mirrors, lenses, so on and so forth. So he understood about the rectilinear propagation of light, and he proposed the nature of light to be corpuscular. Now the same concept was taken by Sir Isaac Newton, and he later on developed that particular concept and assumed and proposed that light is basically made up of corpuscles. Okay, now what do you mean by corpuscles? Corpuscles मतलब particles. And he gave a particular theory जिसको हम लोग बोलते हैं Newton's corpuscular theory. अब Newton's corpuscular theory, what it basically focuses on? There are certain different points about it which we have, which we need to understand in order to understand the next part about wave nature. So ये first type of nature of light, which considers that the light is made up of corpuscles, as in particles. So what Newton's corpuscular theory it focused on? The very first thing, the Newton's corpuscular theory said that it is made up of corpuscles, made up of particles. What he said, that every source of light, it emits the light in the form of particles, which are considered to be corpuscles. Now to elaborate about these corpuscles, he said, how are these corpuscles, how are these particles? The particles are there perfectly elastic, they are rigid, and they are weightless. Perfectly elastic means what? Even though there is a change in shape, they are able to regain their original shape back. Rigid means what? They are stiff, not easily breakable. That's how the rigid it is actually in this context used. Weightless means they don't have any mass, or even if they have, it's very small that we can neglect it. Now the nature of light was further elaborated by the movement of corpuscles, that they travel in a straight line with a very high speed. Now obviously he mentioned that the speed is different in different media. So when it travels from one medium to another, the speed it changes. Now he elaborated how we are able to see anything. So he said that these corpuscles, they enter our eye, they fall on retina. There is some type of reaction which takes place along with the retina, and we get a sensation of vision. Means we are able to see. And lastly, this corpuscular theory focused on the availability of colors. So what he said that the different colors of light are due to the different sizes of corpuscles. Obviously, he actually proposed the actual sizes and the color, but again, we don't have to go into details of them. That sorry, the different colors are due to different sizes. So maybe for red color the size is different, for violet the size is different. That is what he proposed. So this was the Newton's corpuscular theory, which was based on René Descartes' original assumption about the light, that it is made up of particles. So using this particular theory, they could explain the different phenomena. Maybe like reflection hai, refraction hai, inverse square law, which is associated with the ray of light. So these explanations could be given, but this particular theory has several drawbacks. There were some problems with the theory, and those problems are what we are going to see. So what are the problems this Newton's corpuscular theory had? Now, obviously, the reflection and refraction could be explained. Complete reflection, complete refraction. But what about partial reflection and refraction? We have already seen that a light, it reflects partially as well as completely. ये तुम लोगों ने lower standard में already पढ़ा हुआ है. What about partial reflection and partial reflection? That part was not able to explain, or Newton's corpuscular theory could not focus on that particular part. Also, it was unable to explain different other concepts like interference, polarization, diffraction, so on and so forth. So this part was not explained. Thirdly, the velocity of light as per this particular theory. Okay, I'm getting question. Ishwar, which screenshot? Previous slide, beta? Okay, I'll go back. Just quickly take a screenshot. Okay, Neeraj is asking what are corpuscles? Corpuscles matlab particles. It's just a fancy word for particles. Okay. Okay. So another point, it could not explain interference, polarization, diffraction. This you might have heard. ये क्या क्या है हम लोग इस चैप्टर में देखने वाले, so you don't have to worry about ये exactly होता क्या है. So these phenomena about which are also part of light, interference, diffraction and all, this particular concept was not able to explain properly. Thirdly, in this particular theory, by a mathematical analysis, what this theory suggests that the velocity of light is more in denser medium and less in rarer medium. Now we know that it is other way around, that the velocity of light is less in denser medium and more in rarer medium. So this was all, obviously it was wrong. So that was another drawback of the Newton's corpuscular theory. And lastly, if we are saying that a source of light is emitting particles, actual particles, means what should happen? that slowly after a certain amount of time, the mass of the source should reduce, right? Means what? For example, assume करो यहाँ पे एक picture दिखाया मैंने तुम लोगों को, ये है अपना source of light, and you can see these particles which are being passed in different directions. What we have assumed that they are weightless, but obviously since they are particles, they will have some mass, maybe very small, but they will have some mass. So eventually, for every time when the light is getting out of this lamp, at that moment थोड़ा थोड़ा मास तो कम होना चाहिए, बट ऐसा होता है क्या इन रियल लाइफ? नहीं होता. Means what? That this assumption of corpuscles is obviously wrong. That light is not made up of particles what we are thinking them to be particles. So obviously some extensive another concept was required in order to explain all these drawbacks, and then came into existence. The part which we are going to focus on is the wave nature of light. Okay, now before we move forward with her wave nature of light, do we have any doubts till this point? Bolo re, yes or no? Okay, good. Okay, do we have someone new? Mohin. Who's Mohin? Mohin? Are you new? Okay, so this is your first lecture. ठीक है, कोई problem नहीं. Okay, so let's continue from this. So that was the part about Newton's corpuscular theory or the particle nature. Obviously, it's suffice to say that there were some drawbacks, and to overcome those drawbacks, to circumvent those drawbacks, there was a necessity of some alternative theory. And that was the alternative theory which was proposed, that a light is basically a wave. So now comes the another theory about wave nature of light, which was given by a scientist, a physicist, Dutch physicist to be precise, Christian Huygen. Now in 1668, so it was long back, 400 years back, he proposed this particular theory about wave nature of light. Now what he considered, that the light is in the form of waves, and why the waves are created or how the waves are created, they are caused by the vibrations of the particles. So we already are familiar, we have already seen the wave nature of anything for that matter, how the waves are connected, how the wave motion takes place. So when any particle it vibrates, it creates a wave, maybe transverse, maybe longitudinal again, but a wave is created, a disturbance is created. So similarly, a light is a wave which is created by the vibrations of those particles. Now this particular wave nature, what are the advantages? What is the basis for the wave nature to circumvent the drawbacks we had in NCT, which is Newton's corpuscular theory? So this was the concept. The explanation about interference, diffraction, polarization, lots and lots of different things can be explained using wave nature. We are going to see all these concepts later on. Also, laws of reflection and refraction, they also could be explained using wave nature of light. Diffraction, basically which deals with the shadows which are formed or not formed for that matter. So those shadows which are caused by objects, in general sense, diffraction or patterns of diffraction can also be explained using the wave nature. And lastly, the analysis, analytical part, mathematical analytical part, which was about speed and wavelength of light. That also could be done using this particular concept, wave nature of light. Now this part, just to give you an idea, which I have not incorporated over here, but just to give you an idea, this part is dependent on electromagnetic waves. Now this was given by Maxwell, and this Maxwell's equation about electromagnetic waves and the energy which is associated with it was the basis for Huygens principles or Huygens wave theory of light. So based on that, the existence of the waves and later on the wave nature of light was created by Huygen. So now we are going to see what are the principles, or not principles per se, what are the points which we had in case of Huygens principle. Okay. Now basically, before we move forward with the Huygens principle, let's quickly go through another type of what we can say, the nature which we come across, or most commonly which we consider, is what we call it as a dual nature of light. Since light is considered as a particle, at the same time it is considered as wave. So light is supposed to have particle nature, at the same time it's supposed to have wave nature. अबे ऐसा कैसा हो सकता है? ऐसा होता है depending on the situation. So different situations, they call for it being a wave and it being a particle, which we call it as a dual nature or wave particle duality of light. Now obviously we are not going to focus on particle nature as of now, but definitely we are going to consider them when we go for the chapter regarding atoms and nuclei. In that you have that, you already are familiar, I'm guessing, what the particles of light are called as. They're called as photons, and these are the particles which we consider the particles of light, photons. So photons are the particles of light, and the collection of photons, they travel in the form of a wave, giving us the wave nature and particle nature at the same time. So which particular phenomenon are dependent on the particle nature of light? बहुत सारे, जिसमें से एक हम लोग definitely करने वाले हैं, which is photoelectric effect. Another, we have Compton effect as well. Lots and lots of different effects we have regarding particles. Solar cell are the part of this only, photoelectric effect for that matter. So this is about the dual nature of light. So even though Newton was wrong in the assumption, he just needed a different direction in order to understand it as a particle. So for the time being, we are not going to focus on photons, we are not going to focus on particles. We are only going to focus on this, which is wave nature. That's why the name of the chapter or the topic we have as wave optics. Optics, what is the light, wave, the wave nature of light. Now, let's start understanding light as a wave. Okay, so before we start with light as a wave, obviously हम लोगों को पता है, I told you that it is the basis उसका था electromagnetic wave. So light is basically an electromagnetic wave. We know, we have, I'm guessing, mucked up definition that light is a form of electromagnetic radiation which causes sensation of vision. Now the waves, what are the nature of the waves? We know that the nature of the wave is, it is transverse wave. And obviously the transverse wave, but how the transverse wave, or which type of transverse wave? This transverse wave, it consists of different fields. Which fields? electric and magnetic fields. I told you it is an electromagnetic wave. So we have electric field and a magnetic field which are oscillating. Both of them oscillate in the form of transverse wave. The most important thing over here to focus on is that these both the fields are perpendicular to each other. Since they're perpendicular to each other, you have to imagine that in the 3 dimensions. Okay. For your help, I'll give you something over here to focus on this. Or if this GIF is too much for you, I'll give you a diagram as well. So you can imagine this. If this is the electric field, this is the direction of a magnetic field. And since they're oscillating continuously, both of them together, they constitute this electromagnetic wave. So whatever be the direction of propagation, like here it is shown the direction of propagation, maybe it is the right side, and this is how the electromagnetic wave or a wave of light is considered. Now, do we need any medium so that a light can travel? So obviously you're familiar with the answer as well. No medium is required for the propagation of light. Light can travel through anything. It can travel through vacuum. It does not need any medium. It can travel through solids. It can travel through liquids, gases, even vacuum, where there is no medium is present. Now, speed of light, which you already are familiar with, which is 3 lakh kilometers in 1 second for vacuum, obviously. Now, the speed of light is dependent on the refractive index of the medium, which you have already done in your lower standard. Refractive index क्या होता है तुम लोगों को पता है, okay? 11th में भी तुम लोगों ने पढ़ा है, 10th में भी तुम लोगों ने पढ़ा है. Refractive index gives you the velocity of light in that particular medium, the density of the medium. Higher the refractive index, lower is the velocity, higher is the density. So refractive index space speed of light is dependent, which in terms dependent on the permeability of the medium or permittivity of the medium. Now, I'm guessing these might be new terminologies to you, but for the time being in this context, permeability or permittivity means permission. They are related to permission, whether the medium allows the particles or the waves to travel through them or not. उसको बोलते हैं permeability or permittivity. For the time being, इतना याद रखो. Actually, they are not that easy, but for the time being, just remember these are related to the permissions being given by the medium, whether the particles or waves can flow. So obviously, refractive index is dependent on whether the wave or the particles can flow through them. So speed ultimately is also dependent on permeability and permittivity of the medium. अब refractive index तुम लोगों को already पता है, it is ratio of velocities. It is the for absolute refractive index, it is the with vacuum velocity of light in vacuum and the velocity of light in that particular medium. So that part again you already are familiar with it. Now another thing about light as a wave, we know that wave has a length which we call it to be a wavelength. And a wavelength for light, they range from very small to very large. Very small being in femtometers. I'm guessing you're familiar with femtometer. Femtometer is 10 raised to minus 15. Okay, nano pico के तक देखा होगा. Pico is minus 12. Femtometer उसके नीचे आता है. Okay, pico आता है 10 raised to minus 12. उसके नीचे आता है femto, which is 10 raised to minus 15. So you can imagine how small it is. So it is in femtometers, so very small भी है, and very large, which is in few kilometers or few hundred kilometers for that matter. So the order of increasing unit goes on changing. Okay, I think I have included a table over here. I'm not sure about it. Let's check. Yes, we do have a table over here. This particular table you can see that the what we can say, these all are types of electromagnetic radiations, electromagnetic waves. You can consider the spectrum of light. Okay, light is not only visible, बहुत सारे type के light होते हैं, infrared भी light ही है, ultraviolet भी light ही है. So you can see that is 0.0001 nanometer, मतलब कितना होता है वो femtometer में ही जाता है, pico और femtometer में. And as high as 10 kilometer as well, radio waves, we do have waves which are higher wavelength, more than 10 kilometers as well. So we have the wavelength in all the ranges, starting from picometer, femtometer to kilometers as well. So this is about the general concept of light as a wave. Now, obviously, we are familiar with the visible spectrum, which goes from 0.4 micrometer to 0.7 micrometer. अगर nanometer में चाहिए, तो 400 nanometer to 700 nanometer. Again, we are already familiar that the waves of different wavelength can be only perceived by our eyes, depending on the color of it. Now, visible range के बाहर we cannot see anything. Again, I'm guessing you're familiar with that as well. Okay. Now, before moving forward, do we have any doubts in this? Bolo yes or no? Okay, good. Now, let's move forward by understanding about Huygens theory. Okay. Now, before we understand Huygens theory, we need to understand something about, we are always going to come across a specific concept that we always consider a source of light. We always consider a source of light, source of light, source of light. So what exactly do you mean by source of light? So basically there are, generally, broadly speaking, we have two sources of light, which is primary source of light and a secondary source of light. So let's first understand what is meant by a primary source of light. It is a source of light which emits light on its own, means it has its own light. It is not dependent on anything for its light. उसको बोलते हैं हम लोग primary source of light. Now, when we consider primary sources of light, there are different types of primary sources of light, right? Now, why primary sources of light have their light on its own? It can be because of different reasons. Okay. For example, the first one, due to high temperature. Now, due to high temperature, right, because of very high temperature, that particular object is able to emit light. What are the examples of that? Maybe because sun has a very high temperature, that's why we get a light. Or maybe sun के जैसे और कुछ तो भी, maybe stars, they also have very high temperature, right? Maybe take a very small example, maybe a flame or something which is heated to a very high temperature. So all of them have high temperature, that's why they have light, and that's why they can emit light. Second, what can be another reason for being a primary source? The second reason can be the effect of electric current which is being passed through them. Okay. Now, when an electric current, generally when it passes through any object, the concept I'm guessing you're familiar, a very high amount of heat is created. And again, referring to the first point, if the high amount of heat is associated with it, obviously it will emit light. So to give you an example, best example of it, I'm guessing we use on daily basis, or maybe a tube light. Oh, okay, no, not that tube light, a tube light. which we use on daily basis, right? Another example, TV. It works on the same principle. Electric current passes through it. You get light, maybe a screen of your mobile phones, same principle, so on and so forth. Third reason why they can have their own light, because of third, chemical or nuclear reaction. Now, nuclear reaction is chemical reaction, but since it is comparatively specific or precise, focusing only on nucleus, due to chemical reaction. Right? To give you an example, the best example of light coming out of due to a chemical reaction. I'm guessing you're familiar with them. The fireworks or the firecrackers. What is the concept? You have a chemical inside. When it ignites, you get a very high amount of light. तो वहाँ पे actual क्या होता है? Chemical reaction होता है. We know that the reaction is exothermic. I'm guessing you know that. Exothermic matlab kya? Very high heat. Again referring to the first point. Because of high temperature, it emits light. Or maybe you have studied something about nuclear reactors. Same concept, the reaction on nuclear level. You know, chain reactions, nuclear splits of nuclear fission. You have studied them. तो होता क्या है उसमें? Again, very high amount of heat is released in nuclear reactions. And again, referring to our point number one, high temperature results in high heat. So these type of sources which we have are generally referred to as a primary source of light. So this is very important. This is a primary source, and whenever here on onwards, whenever we generally say that we are considering a source of light, generally we refer to a primary source of light, not the secondary one. Okay? So once again, we will be using lots of assume there is a source of light. So which source are we referring to? We are referring to the primary source of light and not the secondary source of light, so that you won't have any confusion later on. Okay? So this is about primary sources of light. Moving on to the secondary sources of light. Primary sources which have their own light. So you would have guessed it, secondary sources of light means they do not have their own light. They cannot produce or do not produce light on their own. So unko still, why we are considering them as a sources of light? Because this is important. They receive light from some other source. Maybe due to reflection, maybe due to scattering, maybe due to dispersion, anything. Either reflection or scattering, most commonly due to reflection, they receive light from some other source. Other means some primary source, again, usually. That's why they are called as a secondary sources. Means they don't have their own light, they take light from some other source and still give us light. So that's why they are called as secondary sources of light. Now, what are the examples of secondary sources of light we have? Now, lots and lots of examples of secondary sources, right? The most common example which we have, the moon. Moon is the most common example. Even at night, we say we have a moonlight. Obviously, moon, it does not produce its own light. It produces or it reflects light which it gets from the sun. So even though it does not have its own light, still it gives us light. That's why we consider it as a secondary source of light. Okay. Yes, Sujal, spelling is wrong, but the concept is correct. We can consider a mirror as well, which is a secondary source of light. And no, Neeraj, radium is a radioactive material, so it is a primary source of light because it creates its own light due to reaction, chemical reaction, to be precise, due to the nuclear reaction for that matter. Okay, Neeraj? So radium secondary नहीं है, radium is primary. sun also have absorbed. sun सिर्फ रिलीज करता है रे, sun किधर absorb करता है light? I didn't get your question. एक मिनट रुक. अगर माइक है तो पूछ ले. Okay. Sun absorb light if you are considering in the sense of reaction. उसमें से जो light emit होता है, then yes. If you are considering that it is bouncing off of something and it is reabsorbing, तो वैसा नहीं होता. But yeah, if you are considering that there is a reaction, I'm guessing you know that nuclear fusion it takes place, उससे जो light निकलता है, तो yes, वो absorb होता ही रहता है उसमें. So this, that is correct. हाँ. So obviously planets है, the moon है, moon के जैसे another planets, all other planets, almost all other planets. So, not only moon or planet, not only these big huge objects, but small objects. Planets की comparison में like human beings, like animals, plants, all of these, even though they don't have their own light, they reflect light off of, for these three last cases, most commonly sunlight, and they are considered to be the secondary sources of light. Okay. Now, most commonly what we see on daily basis, the examples which we have seen, the moons, the planets, humans, animals, so on and so forth, they are mostly secondary sources of light, with exclusion of tube lights or torches or TV. So most commonly what we have, they're secondary sources of light. But here on onwards, whenever we are going to consider a source of light, we always mean that it is a primary source of light and not the secondary source of light. Okay. Now, any doubts part? Now this was just about the sources. So here on onwards, whenever we deal with some type of source, always remember that it's a primary source of light. It can be anything. So it's a primary source of light. Now, looking at a concept about Huygens wave theory of light. Okay. So actual wave theory which was put forth by Christian Huygen, and about the characteristics which are included, which was given by that scientist,